To the next one, and we're going to be talking about grid connection of photovoltaic utility scale. Now, I had to have that explained to me, what that exactly means. Now, we have residential scale, then comes the commercial scale, and then comes the utility scale, right? From the sizes. And from the modules to the grid connection, the question is, what happens in between? And to answer this, we have the global head of photovoltaic utility scale here today. So please welcome him with a big round of applause. Here is Dorko Eliashevich. Almost. Welcome. You got it? Say the name again.
Dorko Eliashevsky. So
Eliashevsky.
You
it's
have
actually
to train
way
it, huh?
easier.
Just say Dorko, please.
Have fun.
Thank you. So I found it very interesting what Gabriele told about the triple-digit megawatt power plants. And in fact, we are looking also to the sea laser and how to combine it with our utility scale PV. Please allow me to give you first a little bit an overview about the market and what the analysts are saying. If you're looking for a long-term view until 2040, very long term, I have to admit, then you can see there is a bright future for renewables and especially for PV. 3.9 trillion US dollars will be invested in PV only, PV utility scale. And that is 33% of all the invests. And this is more than it will be invested in wind. Wind will represent 24% of it. Together, more than 50%. And why is that so? Because one very clear fact we could see over the last year, during the auctions from different IPPs, we could learn that the prices are dropping for PV dramatically. This is coming from the scalability effect on the photovoltaic modules. So the modules are getting produced cheaper and cheaper. So what we could see is in Mexico, 3.9 US dollar cents per kilowatt hour. Then we could see in Chile, 2.8 US dollar cents per kilowatt hour. And at least in Dubai, 2.4 US dollar cents per kilowatt hour. And the analysts are saying during the next 12 months, it will go for sure below 2 US dollar cents per kilowatt hour. You will never ever see this on the conventional power plants. So PV, and this should go in our heads, PV utility scale will be the cheapest source worldwide for electricity. And this is, of course, then affecting into the deployment of PV fields. They are getting larger and larger, and therefore, Siemens is taking care also for the grid connection. So what we are offering are not the modules and not the rackings, but we are focusing on the power conversion. So I'm from EM, Energy Management, and Energy Management is looking after the power conversion. So we are taking off the energy coming from the PV, which is the DC power, bringing it into the medium voltage, so-called medium voltage inverter station. The medium voltage inverter station is the key element here, the most important one. If you are just looking to the shares of value, the complete PV power plant, if you say this is 100%, the electrical balance of plant is just representing out of this value 15 up to maximum 20%, not more. It's just a small part, but a very crucial part. Technically seeing a very crucial part. If this is not working, the complete power plant will not deliver you the electricity. So it has a direct effect to the harvest and the efficiency of your field and also on your return of invest. So therefore, it's so crucial. So what Siemens is doing, we are supplying to you, we are offering to you a turnkey system saying, okay, from the combiner box on until the grid connection, and even more, also operation maintenance, SCADA system, all of the other things we can supply to you. So having a look to the next slide. I hope it's working now. Yeah. So here you see what we are going to offer. You're speaking about engineering. We are speaking about the planning of the eBoP, financial concepts. So also SFS has some very attractive financial concepts which are providing for you, for example, deferred payment or leasing models, whatever. So here we can help as well. We are taking care for procurement, for the commissioning, warranty, and operation maintenance if everything is installed and commissioned. And afterwards also looking for repair services if something has happened. So we are able to give you an availability guarantee and a performance ratio guarantee to make sure everything which is coming out of one hand from Siemens will work properly. When we are speaking about utility scale, you have to think about the size of those PV installations. As I mentioned, we are already in the triple digits. So we are starting thinking on 30 megawatt, 50 megawatt upwards, not below. And here you can use the full strength of Siemens. We do have excellent products coming from the medium voltage and systems. And here you see the first integration of that in the medium voltage inverter station. So the inverter is one part, it's a very important part, and then afterwards we are transferring the power into medium voltage. So the low voltage which is coming out of the inverter will be transferred by a transformer to medium voltage. And then going into the well-known products, the ring main units, the switchgear stations, all of that which is belonging to the portfolio of medium voltage and systems. And afterwards, we are transferring this with a high voltage transformer also to the high voltage grid. So this is what we are doing. What we are not doing, we are not a full EPC, as you can see it here on the slides. So we are not taking care for the blend preparation. We are not taking care for the modules and the rackings and all of those things. This is not the strength of Siemens, but the strength of Siemens is the conversion of the electricity. So have a closer look to the medium voltage inverter station. This is a very important element in the solution. So here you can say that if you see they invest in the development of a new inverter, this is not just going into the development of the mechanic, electromechanic, electro conversion of DC to AC. It is also a lot of software in. We are speaking about the harmonics. We are speaking about reactive power. And what is also important to achieve the today's goals of very cost-efficient production, we have to see that this element is also cost-efficient as well. Just to give you an imagination about the size, this, what you see here, is a so-called open skid, and the size is typically 5 megawatt. Could be 4 or less, but 5 megawatt is the most cost-efficient today. And if you are going for a 5 megawatt, it means in a 50 megawatt field you have 10 of them, in a 500 megawatt field you have 100 of them. And they represent more than 50% of the cost of the electrical balance of plant. So very crucial for us, very sensitive item. We are speaking here about power electronic and all the mechanism to protect that. And think about cybersecurity. So we are speaking here a lot about digitalization. You can control here very, very sensitive parameters, like the harmonics, for example. And if a hacker would coming into such a system, of course, that could disturb the grid in total. So that is one of our focus in the monitoring control system and the firewalling and all this, what we are doing to protect the system as best as we can. So if you are looking one after the next of those three parts, as I told you, the ring main unit, this is for protecting your circuit, protecting that in failure case, all the other inverters, if you have 100 in a field, of course you don't want to get disturbance going into the others. So therefore, we are placing ring main units in here. We are going for the medium voltage with our transformers coming from TR. We have a wide portfolio here. And the inverters are, according to our Synacon family, we are naming ourselves as inverter agnostic. So what does that mean? So we are looking also for the best solution on the inverter part. And as you might know, we are cooperating also with SMA in this field, with a world-leading inverter supplier, and working out the best inverter for our complete electrical balance of plant, together with SMA as well. So everything is starting from one point, and that is the starting of the discussion. We are looking very intensively on the so-called single line diagram. And just to give you an overview on that, it's very technical, I have to admit. But from below there is coming the power from the solar modules, and then you see the combiner boxes. And there are a lot of combiner boxes combining the strings, the cables coming from the modules. Why we are starting with the combiner boxes? Because here's the monitoring starting. So we are looking with the combiner boxes into the several strings and have an early detection of failures if there is something happening. And then it goes to the bunch of inverter stations. And the inverter stations, as I said, in high quality, high efficiency, made for harsh environments, they are converting then the electricity into medium voltage. Then in the picture you see everything is collected, and this makes it very visualizing clear. Everything will be connected into one big substation, connecting all the rings coming from the different inverter station, and then transferring them to the high voltage transformer and feeding it into the grid. So in general, this is our short explanation about that. I have to say that we are here in a digital world, and monitoring and control is an extreme important subject. Just think about all the modelings we have to refer to and we have to deliver to the utilities for guaranteeing the grid compliance, and also thinking about all the monitoring control subjects over the cloud, remote control, which has to be protected via our power plant controllers delivered by digital grid, for example. So Siemens can deliver a complete portfolio for this solution, everything out of one hand, and if customer has a need, also financed by Siemens with very attractive financing modules, and that is exactly where the customer are looking for those large power plants. They are thinking about partners which are, of course, also existing after 20 years from now, having a good bankability and a strength in all fields. That was my presentation. Thank you very much for this. If you have any question more, you can visit us on our dialogue station, which is on booth number 27. You will find us there over, and we would be happy to answer your question. Thank you very much.
We cannot